Hello, my name is Jeremy and I'm building a 1937 Auto Union Type C replica. Today we're going to be taking another 6-speed Subaru transmission and converting it to be used as a mid-engine transaxle. Let's get to it. So I sold the other transmission that was the WRX 6-speed, which is basically the standard 5-speed Subaru split case transmission. So the case is made in left and right halves and bolts up the middle with an extra gear added. So it's not very strong. It's actually pretty weak. Cable shifted, pretty meh. So I sold that to a guy, I believe he's doing a 914 Porsche project. And I bought a STI 6-speed, which is the big heavy-duty 6-speed that is good for, I believe, over 600 horsepower, completely bone stock, and that's going through an all-wheel drive system. On this 6-speed, since it's a lot more beefcake, I decided I wasn't going to do the cheapo, chintzy, welded up myself version like the first one I did. So I reached out to the guys at Subarugears, talked to Todd, and he was super helpful. He showed me they have a product specifically for this that is a mid-engine rear-wheel drive kit for the 6-speed STI. And the kit I got comes with this billet aluminum plate, very nicely made, bead blasted, it looks like, after the CNC work. This deletes the rear output to the rear-wheel drive on a standard Subaru, and the shift thing goes through here. Some kind of sensor goes here, I think. That's really nice. And then it comes with this, which is a beautifully machined and ground lockout collar that basically eliminates the rear differential in the transmission, which would ordinarily split the power between going out the rear output to the rear axle and then back to the front differential inside the transmission. This locks that out, so it only sends power through to the front differential. And then this thing, which I don't know what it's for, it's a lock collar, so I will have to pull the transmission apart before I actually know where this goes. But it has 2 set screws, and it's probably super important. So this is the STI 6-speed. You know, the case does not split up the center. It is instead basically a barrel or sections of barrel with a big cast iron center section. Otherwise, as far as the bell housing and input shaft, that's all identical. I got this one with a slave cylinder and the throwout arm. So that's nice. It has all of the wiring as well for doing the backup and probably other stuff as well. I don't know enough yet to know. It also came with the entire shifter mechanism, which is nice. So what I will do with this, basically left and right rotates the shaft, and then there's a in and out, which is your 1, 2, 3, 4, 5, 6, and then this guy, when you pull up like that, pulls that little lever, and that is your reverse lockout. So when you go there, and then it allows you to go over one more notch to the back for reverse. So what I'll do is I'll basically copy this system that guys use in like Formula V for Volkswagen transmissions, where you just have basically a drive shaft that comes back here, and then we'll rotate this and move it forward and backwards from up in the cockpit, and then I'll just run a second little cable, or not a second, I'll just run a cable from that also up to probably this shifter, because it has the nice pull knob. So here you can see rear output. It came with this chunk of the drive shaft, so just cut off, which is nice. Comes with has a dipstick, which is also cool. And then right here is the front output, which would go to the front axles in a normal car, we'll be driving our rear wheels. So I'll just run stock Subaru axles. I may have to get them shortened. All of this stuff will get deleted. But first of all, we have to put on our rear delete kit. Okay, you can see I have it up on the nose. I did have a spill because it was not drained, but I figured you couldn't ship it without it being drained, but it wasn't. So first thing we're going to do is drive this roll pin out that holds the shifter on, and then we'll start taking the bolts loose that hold the entire tail housing on. So here you can see where the power comes in and out. So this shaft, I believe, is the drive out of the transmission, which would spin the carrier here. And then this guy is the one that shunts power back through the transmission to the front diff, which is down in here. And so this collar, you can see, has splines inside and out, just goes right over that and physically locks those together. And then this guy, I'm assuming I have to cut this shaft off right about here. And then this guy goes down over that with these two set screws to keep this from coming off. Because if you see the case here, it's totally flat where it sits over that. So yeah, I gotta cut the output shaft off. That'll be fun. I'll have to ponder on how to do that. It looks like I will also have to pull the little bearing and seal out of there where the shift fork runs through. So it's the next day. I'm going to try a pipe cutter. I don't think it's going to work that well because this is a shaft, so it'll be hardened. What I'm going to do is I'm going to set this collar on here, mark it, and then cut it off. Or try to. It is hollow, so who knows, it might work. But when this inevitably doesn't work, I'll bring you back for the next step. So as I expected, this didn't do anything. I don't know if you can see or not. Focus. All it did was dull this blade, just made it into a flat wheel instead of a cutter. It has a spare cutter here, so no big deal. Yeah, useful experiment. So my next version, V2 here, I have packed the bottom in there with blue paper towels, and then I have about, I don't know, 6 or 8 layers total of blue painter's tape. You can hear it's, well, the microphone's facing the wrong way, but it's quite thick. And then I'm going to use the paragon of cutting anything you want to cut when you absolutely positively got to cut everything in the building. Abrasive cutting wheels. So what I'm going to do before I do that, though, is I'm going to put a layer of grease right around this to capture any grit that might come down. I don't want to use silicone because that will set up, whereas a nice thick layer of grease will capture everything, and then I can pull this off and clean that grease and metal mixture completely off with solvent and reinstall the part. So here's my mark. All right, here, this little line, I don't know if you can see, there's a very tiny discoloration where the wheel tried to cut through on the pipe cutter to no luck. So what I'm going to do is I'm going to come in at a slight angle and then rotate this, because it still will rotate. I'm going to come in, droop, rotate a bit, droop. So it'll be kind of like almost a bowl. And then once this is out of the way, I'm gonna cut above my mark, so I'm gonna cut up here somewhere. Once this is out of the way, I'll come in with a flap wheel or a sanding disc and dress it down so that it is nice and pretty and a nice even finish. Because it's so far out here and because it's thin and what I'm doing is fairly quick, it shouldn't affect the heat in this, at least not down here in the splines where it matters, so that should be fine. This is not how you're supposed to do this. I'm sure you're supposed to take this shaft out of the transmission, but I don't want to do that. Something else I didn't remember to tell you, I took an earplug and shoved it down the hole because this is hollow and that does go into the inside of the transmission. See, I did mess up. I touched the edge of the case here, but that's okay. It's far enough in and it's not deep enough to be a problem. I'll just have to, it's just something to be aware of. I did mess up, but here you can see it's finished. And fresh off of everything, I can still hold my thumb on it, so it didn't affect the heat treat at all. Zero. See here the burn marks from where the sparks hit it, but otherwise I feel like it caught everything really well. And if we look down in here, there's nothing, no grinding debris of any kind. This grayness is from the friction material in the transmission. None. There is no contamination, which is what we wanted. So I'll pull this off, clean the shaft and this coupler very thoroughly, put it back together. So here we have it. It has a tiny amount of play, which I'm fine with. If it's driving, it'll have torsion holding it in place. It can't come off, so I'm happy with that. It's like a 32nd of an inch, which is fine. So now let's grab our cover, see if it fits. It does not. Why does it not? Because of the dowel pins. Ah, interesting. It definitely needs the bushing to hold the shift fork or the shift rod in place. But I'll have to transfer now the stuff for the reverse lockout and get some bushings and seals for this, and then we're ready to pop her back on. But look at that. I really also, the aesthetics of this are much closer to the original Auto Union transmissions with the big kind of ribbed barrel shape and the more blunt tail. This is also quite a bit shorter now than the other transmission I had. This is, I think they said it makes it 735 millimeters long, which is some number of inches. Right here, I'll tell you. Which is nice because the V12 is fairly long. And this has quite a bit of overhang from the axles back, and there's not a lot of tail on the car, so I like that this is shorter. I'm holding the mic, I apologize if it's bad, but I have the parts out of the rear housing. This is the reverse lockout with its spring. This is a plungy do-bob. This is another plungy do-bob, a different one though. This is a tiny plungy bob. Roll pin, seal. This has an actual roller bearing, which is mind-blowing to me because this could be a bushing. I mean, it rotates a fifth of a turn, maybe a quarter of a turn, occasionally. It's just mind-blowing to me that this has a roller bearing, but that speaks to the quality of these transmissions that everybody talks about. So cool thing, this cut in the end of the reverse lockout lever is actually, so you have this little legs on the spring. One of those goes in that hole, and the other one goes inside this thing in a little another hole. And so once that's in, you put a screwdriver in that, load it, and then this hole here gets a roll pin driven through it that then holds the shift lever on that keeps this in tension. It's really ingenious. So I'm going to put all this in this case. I have everything except this is where the shift rod comes out. I have everything except that, and we'll pop this in. Yeah. Supposed to go good. So I have a problem here. This is the detent pin, which goes in this bore. And you can see it goes in and out nice and freely. It will not go into this bore. I tried whacking it with a hammer even, just as maybe it was a burr from where they bored another hole. So this pin, if you look, is just a smidgen under 13 millimeters, which you would expect for a 13 millimeter bore. It has 0.04 millimeters of clearance, so it can slide back and forth. However, this is a 1/2 inch diameter transfer punch, and it fits quite snugly in this bore. And you can see it 12.62. Take another one, 12.63, somewhere in there. So what I believe has happened is that when this was made on a CNC mill, somehow a 1/2 inch diameter tool got used to cut this bore, which is just marginally under, 1/3 of a millimeter under 13 millimeters, which is what this pin is. And this is a hardened pin. So that's the only thing I can think of that happened. So I don't have a 13 millimeter reamer. I have 10, 12, 15. I have a couple 15s. I don't have a 13. So I'm at a standstill here. It'll be cheaper for me to just buy a 13 millimeter reamer and bore this hole out than it would for me to ship this, to take all the stuff back out and ship this all the way back to Australia and then have them diagnose whatever the problem is, this bore being too small, which is odd because this plug fits it beautifully. Like everything else has fit very nicely. I have the seal and the bearing put in here. This is for the shifter. I have the seal and the bearing here. All fits really nice. So it's really odd. These are, I believe, 8 millimeter pins. They fit really snug. Like it's super well made. But this bore is too small, so I'm gonna email them and just verify what's going on. But I believe the cheapest and quickest option for me is just gonna be to take a 13 millimeter reamer and ream this hole out to 13 millimeters and then go from there. So here are the bolts. This is one of the bolts for the engine. And I've made up these long time ago for normal work. These are just bolts that have the head cut off, a taper cut with a slot. And what you do is thread these in to an easy to get to hole, like so. And we'll put one up here, and then those will guide your transmission in. So this one is dramatically heavier than the other one that was on here. A bolt here. So that's going to be the end of this video. I'm going to call it there. The rest of what I need to do is just reinstall that the shift lockout here and put the lever back on, which is relatively minor, and then pop this cover off, do that, and then reinstall it with the correct hardware that I have coming after I ream the hole out, of course. So conclusions, I emailed Todd over at Subarugears about this with my theory that it was drilled with a 1/2-inch drill bit, and he shut that down, said there are no 1/2-inch drill bits in Australia. So I don't know what the problem is. He said he would check the others before they go out. Maybe he said the drawing calls for this to be a 13mm bore plus or minus 0.01, which would fit the pin. So their drawings are correct, but somewhere he thinks maybe in the production department they missed that step. Overall, I feel for the price that this is, it should be a much more polished product. I don't feel like this was $1,100 for those 3 pieces, and that's American. That's $1,100 US, which included shipping. But I feel for that price, I shouldn't then also have to spend $50 on a reamer, plus another $30 or $40 on bolts to bolt it to the transmission, since you can't reuse all of the factory hardware. The full kit is $1,500 with the stub axles and the flanges. If you are going to do this, I would email them first to verify that this has been rectified. Overall, they're really the only game in town, so they kind of have that cornered, but I just feel like it could be much better. The fact that the locking collar didn't fit, the fact that this bore is incorrect, therefore you have no reverse lockout unless you buy a reamer and have the ability to measure it and then fix it. I feel like for the price, you should not have to then modify it further yourself to be able to actually use it. So overall, I think I'm disappointed. The actual locking collar, not the locking collar, the actual splined piece that replaces the differential back here was gorgeously made and fit perfectly, but the other 2 pieces didn't fit, don't have the best surface finish. You can see hand sanding marks on this back cover, which I also feel like shouldn't be there on a product this relatively bespoke and this expensive. So take all that with a grain of sand, salt, whatever. I would definitely ask about the reverse lockout pin bore and make sure that problem has been resolved before you buy one. Otherwise, we're golden. It does what it's supposed to do. We're locked into only driving these front axles. This fits my adapter plate, which again, since these will bolt up to any Subaru, I was sure it would, but it's nice to just, verify, trust but verify. This is quite a bit shorter than the WRX 6-speed that I had, and this is dramatically stronger. So no matter what happens with this, whether I go to a later model twin turbo version, no matter what, this transmission will be all I ever need for this car. So that's going to be it for this video. Thank you for watching. Subscribe, ring the bell, the whole 9 yards. And that's it. See you next time.